So another example we might look at that might answer your question. If the doubling time is 6 days and P of t is 30 ounces when t is 50 days, what is P of 0 or P naught? Okay, so and I'm using P now instead of W, but it doesn't matter what letter we use. Since I started writing P, I'm going to stick with it. Model is this, and we know that P of 6 equals 2P of 0, since the doubling time is 6. So you get t is a natural log of 2 over 6. It's approximately 0.115. Now this is going to be the case whatever P naught is. This doesn't tell you what P naught is, but it now allows us to find P naught. Okay, so now P of t equals P naught e to the 0.115 t, and P of 6 equals 30. So P naught equal to the 0.115 times 6, and I don't know why I put an equal sign there. Surely don't need an equal sign. Sorry, P naught e to the 0.115 times 6 should equal 30. So P naught equals 30 over e to the 0.115 times 6, which is 30 over e to the 0.7t. Oh, yeah, I've messed this up. I mean, going around in a circle. We don't use P of 6 equals 30. It's P of 50 equals 30, right? It's after 50 days that we have 30 ounces. So my 6 here should be a 50, and this 6 should be a 50. And now this is not going to be 0.7t. Okay, So let's fix this. And it's, ouch, P of 50 equals 30. And 0.115 times 50 is 5.5, and then you got a 2.5. I think that's e to the how's that, approximately over e to the 5.5. Okay. Now e to the fifth is e cubed times e squared, which is about 16 times 7, which is about 112, 125, 130. And you can calculate this. Something around 0.25 maybe.
I calculated 0.095.
0.095. Better take that calculator back to the manufacturer, but I'll take your word for it. No. Maybe I got one too few doubling times, because we take one more doubling time off of that, and that's about what we get. But 1 times 50 would be 5.5. That would be a little more than 50. 5. That might be 5.7, so it might be closer to 6 doubling times. Anyhow, okay, we'll say 0.1. You got 0.995 or something like that, so I'll give it an extra doubling time and say 0.1. Okay? Yeah, my estimate wasn't very good. Okay, but that makes fairly good sense. So there we have it. Now your question was about having a fraction here, right? And what was the fraction?
The fraction I had example was if a bacteria doubles every half hour, you come up with a model of P of t equals P naught times 2 raised to the power of t over 30. That's what comes up, or how he came up with the presenter. That's something that I'm still trying to figure out. How to understand that.
Well, okay, if you double every half hour, let's just see what happens. Okay?
Yeah.
Okay, let's say we double every half hour, then you get P naught e to the 1/2 k equals 2 P naught. So E, because 1/2 is a half hour, it's e to the kt. Per half hour, you're going to have the 1/2. You get e to the 1/2 equals 2. So that 1/2 equals the natural log of 2 at 1/2 k. So that k would be 2 times the natural log of 2. Now, what you saw was what?
What I saw was the initial amount times 2 raised to the power of t over 30.
T over 3?
30. 30. In minutes.
Okay, then it's in minutes. Okay. Well then, if t's in minutes, because I was doing this in hours, this is for t in hours. So if t's in hours, that's what you have. If t's in minutes, then P of 30 would be 2P naught, meaning you'd have P naught e to the 30k equals 2P naught, and this very quickly gets you to